Today we're going to go over the root test, which is another way to test for convergence or divergence in infinite series. Now, the root test in itself is pretty simple, although you won't see it very often on any calculus test. It's a pretty niche infinite series test. That being said, let's go over the conditions. So if you have an infinite series with bounds and it eventually leads to infinity of a sub n, it will converge if the limit as n approaches infinity of the nth root of the absolute value of a sub n is less than 1. Likewise, it will diverge if the limit from as n approaches infinity of the nth root of the absolute value of a sub n is greater than 1. Now, if the limit as n approaches infinity, the nth root of the absolute value of a sub 1 is equal to 1, then the test is inconclusive and you'll have to use some other test. Okay, so let's get into the practice problems. Let's first set up the limit as n approaches infinity of the nth root of the absolute value of a sub n. Now, an easier and I've found a far better way to write the nth root is to just say the absolute value of a sub n raised to the power of 1 over n. And this just makes it easier to simplify. You, of course, don't have to do this, but it is the same thing algebraically. Okay. As I said, of a sub n. So let's fill that in here. Now, of course, we can divide this 2n by this, multiply this 2n by this 1 over n here. And you can see that we actually just end up with the limit as n approaches infinity of the absolute value of 3n minus 2 over 4 plus 4n squared. Okay. Now, this may be a bit difficult to see because I'm not too great at writing. However, we have two factors of the equation, 3n and 4n, that are raised to the same exponent. And since we're finding the limit as n approaches infinity of this function, we're only going to focus on the highest exponent values in both the numerator and denominator. So we'll disregard this part. We'll disregard this part. Now, since these two have the same exponent value, we will, or they're raised to the same power, I should say, well, we will just look at the coefficients. So we can say that this is actually equal to 3 over 4 squared, meaning this is actually equal to 9 over 16ths. You'll notice that 9 over 16ths is less than 1. And since this is less than 1, we can say that this equation, this series, n equals 0 to infinity of 3n minus 2 over 4 plus 4n raised to the power of 2n converges by the root test. All right, this practice problem looks a bit difficult. So first, hear me out. Recall that if we were to, for instance, take the square root of 9/4, you would end up with 3 over 2. And that's because we actually distribute the square root to both the numerator and denominator. Another way to write square root of 9 over 4 is to say 9 over 4 to the 1/2. And we distribute this 1/2 to both the numerator and denominator, as I just said. And that's exactly what we're going to do with this equation. So let's do just that. We're going to say that the limit as n approaches infinity of the nth root of the absolute value of 6n plus 1 over negative 9 4n minus 1 is equal to the limit as n approaches infinity of the nth, not the nth root, the absolute value of 6n plus 1 over n. I should write this better, sorry. N plus 1 over n over negative 9 to the power of 4n minus 1 over n. God, that's awful. But let's simplify this a bit further. N plus 1 over n is equal to 1 plus 1 over n. And we can simplify that even further. So rather than 1 plus 1 over n, we can say 6 times 6 to the power of 1 over n. And we can simplify this by saying 4 minus 1 over n, also known as negative 9 to the power of 4 times 9 to the power of negative 1 over n. Okay, and from here we're practically done. We can just substitute infinity in for the n's. Let's start off with the numerator. 6 times 6 to the power of 1 over n. Now, 1 over infinity. Now, 1 over infinity is practically 0, so we might as well just say that this right here is 6 to the power of 0. However, 6 to the power of 0 isn't 0. Anything raised to the power of 0, with the exception of 0, is equal to 1. So we're saying that this numerator is equal to 6 times 1, which is just 6, over the denominator, which is negative 9 to the power of 4 times negative 9 to the power of negative 1 over infinity. As I said earlier, this is just 0. And so the entire equation, this entire part of the equation, negative 9 to the power of 0, is just 1. And so we end up with 6 to the power, we end up with the absolute value of 6 over negative 9 to the power of 4. And I don't have to simplify this any further, because I can easily see that this is less than 1. Since this is less than 1, then the infinite series from as n equals 0 to infinity of 6n plus 1 over negative 9 4n minus 1 converges by the root test. That is it for the end of this video. If you have any suggestions, leave them in the comments below, and please like this video as well.